Hi, we're going to look at parts C and D of the problem in which we need to find out the peak diode current and the average diode current. So let's go back to the circuit diagram and see how we can do that. So if we look at the circuit diagram here, the current that is flowing through the diode, how does that flow in the circuit? It comes from this signal source, right? It flows like this, and then it flows through the diode and it flows into the resistance. It cannot flow in the output because it's just an open circuit here. So it has to flow through this resistance and back. So the current is flowing in this loop. So what we notice is that the diode current is the same as the resistor current, right? And also what we see is, what's the resistor current going to be? The resistor current is simply the output voltage divided by the resistance. Does that make sense? Okay, so let's use those to write the equations here. Oops, let those go. So what we have is, what I'm saying is ID is equal to IR, resistance, and that is equal to V out divided by R, where R is 100 ohms, isn't it? So let's write that 100. So ID peak, the peak of the is simply going to be V out peak divided by 100. Now what is the V out peak that we calculated? It was 2.5 volts. So we say this is simply 2.5 volts divided by 100 ohms, and that turns out to be 25 milliamperes. Similarly, if we want to calculate the average diode current, that's going to be V out average divided by 100, and that's going to give you 2.5 divided by pi divided by 100, which is 25 over pi milliamperes, and you can leave it like that. Okay, I mean, you could have calculated, I mean, from this equation you could then have said, okay, I will calculate ID peak directly by plotting ID, or I would have calculated average directly from that plot. You could have done that, but this is an easier way to do the problem.